Welcome to this video lecture. Myself Atul Kumar, working as a assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Jogindanagar. This is lecture number 2 of Relational Algebra. In previous video lecture, I have discussed about set union operation, intersection operation, and Cartesian product operation. So next basic operation in relational algebra we have set difference operation. So what is basically a set difference operation? So I just illustrate you the example with the help of example. What is set difference operation? So suppose we have two relation, one is relation R and other is relation S. It has both relations have attributes A and B. So the degree of this relation R is 2, that it contains 2 attribute, and degree of relation S is also 2. The relation R contains 3 rows, so its cardinality is 3. Relation S contains 2 rows, so its cardinality is 2. So when we apply a set difference operation, it is just represented with the help of minus symbol, and it is just represented with the help of R minus S. So it is a set difference operation, and it the result is A1 and B1. That is, it contains all the rows that are present in relation R but not present in relation S. That is, it contains all the rows that are present in first relation but not present in the second relation. So in the first relation we have a row A1, and A1 is not present in the relation S. So it is the first row of R minus S operation. Secondly, A2 is present in both R and S, so we eliminate this in R minus S. Third row is V1, and it is also not available in relation S, so it is also with the second row of this relation R minus S. So formal definition of set difference operation is, it is defined as R minus S is equal to T such that T belongs to R and T doesn't belongs to S, where T is the tuple or a row. So any row that belongs to R but doesn't belongs to S, it becomes a part of R minus S. Also, set difference operations must be taken between compatible relations. The compatible relations means they have same number of columns or attributes, so their attributes are same. Also the attribute domains of R and S must be compatible or have the same domains. Next we have special relation operations. In relational algebra we have many special relational operations. So these special relational operations focus on the structure of relation. So basically we have selection operation, projection operation, rename operation, and join operation as a special relational operation. So firstly, what is a selection operation? So it is basically denoted with the help of a symbol sigma. So it is also called as restriction operation, and it is used for selecting a subset of tuples according to a given selection condition. So in this kind of operation, there is a condition, and based on the condition we select the number of rows, and these number of rows are subset of total number of rows that are present in the relation. So this means it results in a new relation that contains only those rows of relation that satisfy a specified condition. So selection operation basically select tuples or rows that satisfy a given predicate. So the important properties of selection operation we have, it is a unary operator. Unary means it works on only one table or relation, that is it operates on a single relation or a table. The second important property is it results into a table having the same degree as that of original relation. So if the original relation contains a degree 4, so the resulting relation must have the same degree 4. Also, the number of rows of a resulting relation is always less than or equal to the number of rows of the original relation. Why this is? Because in case of we apply a condition, and based on the condition we select the number of rows, and these number of rows must be equal to or less than equal to the number of rows of the original relation. So for example, we have a relation employee, and it contains three attributes, that is id, name and salary, and we apply this condition, that is a selection operation, sigma salary is greater than equal to 8000. So we select only those rows for which the salary is greater than equal to 8000. So we have 10,000, that is first row, and we have this greater than equal to sign, so we select also the salary that is equal to 8000. We select this row, that is 507 id, then we select 510 id as its salary is 15,000. We also select 512 id as it is 12,000 salary. So the resultant relation contains the same number of attributes as that of original relation, but the number of rows are less as compared to when we compare it with the original relation employee. So this one is the result of selection, sigma salary greater than equal to 8000. So next important operation, we have a projection operation. So it eliminates all the attributes of the input relation but those mentioned in the projection list. So it basically works on the attributes. So it basically works on the attribute. So it basically results in a new relation that contains a subset of columns of a relation and eliminates any duplicate rows. Also it eliminates the duplicate rows, and it contains a subset of columns. So it works on the columns. The selection operator works on the rows, but it works on a column. The it is also represented with the help of a symbol pi, and it helps to extract information or the value of a specified attributes to eliminate the duplicate value. So the main important properties of projection operation is, the first is it is a unary operator. That means it operates on a single relation. The second important property is the resulting table has a degree equal to the number of attributes specified. Suppose if we specify two attributes, so the degree is 2. If we specify 3 attributes in a projection operator, so the degree is 3. So it does not hold commutative property. Also it removes the duplicate rows from the table. For example, we have a relation, suppose person, and we apply here a projection operation. So projection operation contains only two attributes, that is name and hobby. So for applying a projection operation, the syntax is like pi name comma hobby, and on which relation it is applied, that is person. So it contains only two attributes, that is name and hobby. So we select only the rows containing name and hobby. So name is John and hobby is stamps. So we select John stamps, then John coins, then Mary hiking, then Bart and stamps. So this one is the resulting projection relation. Similarly, we have a selection operation on this person and person relation, and the selection condition is hobby is equal to stamps. So we select only those rows that whose hobby is stamp, or we select only those person whose hobby is stamps. So there are only two person, one is having id 1123 and other having a id 9876. So there are two number of rows are selected, but the number of columns remains same as that of original table. But in case of projection, number of rows are same, but the number of columns differ as that of original relation person. Next important operation, we have a rename operation, and it is denoted with the help of a Greek letter, that is rho, and it results into a relational algebra or a relation with name. So sometimes when we apply some relation operations on a relation, then it results into a relation but they don't have any name or renaming. So to rename those relations without name, we use a rename operation, and it is always denoted with the help of a Greek letter rho. So it results in a new name, and the new name either is given to a relation or the attributes of the relation, or both. So it is very helpful in case of operations like join, union, projection, and so other operations like intersection. So this one is basically the query to rename the relation student. So we have a student relation, so we have to rename that relation as a male student, and the attribute of the student is roll number and s name. We have to rename those attribute as s name and name. So basically query relation algebra looks like this: row, then the name the name of new table, that is male student. This one is a male student, then its attributes, new attributes s number and name. Then we select that is projection operation, then we have roll number, then s name, and condition, we select a condition and we apply a condition on student. So the new relation contains serial number and a name, and the name of this table is male student. Next important operation, we have a join operation, and join operation combines two or more relations to form a new relation, that such that the new relation contains only those tuples from different relations that satisfy some condition or a criteria. It is also a binary operator, and join condition is in the form of p theta q. So basically it is represented with the help of this, like this symbol, that is p join, and there is a join condition, and join condition here is p theta q, and it is applied on to relation p and q. So what is a theta? Theta is basically a condition, and it is basically a comparison operator. So the comparison operator may be equal to or not equal to, less than equal to, greater than or greater than equal to. So when we use theta as equal to, so the join is called as equi-join, and it is very commonly used and powerful join in relational algebra and database. So suppose we have two relations, one is employee relation and other is department relation. The employee relation has attributes employee id, employee name, salary, and department id, and department relation has attributes department number and department name. We have just we will apply a join on these two relations. So when we apply a join on these two relations, so what is the join? We are going to join employee and department, and this one is the symbol of join. And what is the condition? The condition is when we join those rows in department and employee that has same departments, that is the department id is equal to the department number. So in case of suppose the first row is 101, employee name is Anurag, salary is 12,000, department id is 1. So if we combine this with this department number and department name, so the first row is finance, and the second row is 103 Anshu and its department id is also 1. So we combine this with this department number 1 as department id is equal to department number, and we just use here department name finance. No, yes, there is a finance as also in case of two marketing. So there is some problem in this example here. There should be if we applying a q join, so this should be 1. There is a mistake in this example, so this should be 1, and also department id should be equal to department id, so this should be 2, and here the result is as department number 1 is finance, so it should be finance, so its answer is finance. And here department id and department number where 2, the result is packing, so here the result is packing. So this is same, but here we have to just write a finance, so there is some mistake in this example. Next we have natural join. So natural join is basically joining all those columns from the first relation to any column in the second relation with the same name. So we join all those in the first and second having the same name. So after applying a joining natural join, the result of this operation is department id 01 finance, and then 01 is marketing, and 02 is packing. Next we have some properties of join. So firstly, the join operations are commutative. Join operations are commutative in nature, that is when we apply a join on p and q, it is also equal to q and p. Also the join operations are associative, means p join q join r, both are bracket, it is equivalent to when we take first two in bracket, and after that when we apply the combination of these two join on with a relation R. Next important property is when we can combine a selection operation with the cross product to form a join. So when we apply a selection operation with the cross product of two tables, then it forms a join. Also the rows whose join attributes are null doesn't appear or don't appear in the resultant relation. So if the rows contains a null, so their join attributes doesn't appear in the resultant relation. More than two tables can also be joined, but it increases the complexity. Also joins are most common used when there exists a relationship between relations, and joins are very powerful operators, and together with the projection form a base of normalization. I will discuss normalization in later on. So basically it is a concept for designing a database tables. So also if the attribute on which join is specified have the same name in both the relations, then the renaming is necessary for the equijoins, as we have to just specify both attributes in case of equijoin, but in case of natural join we have to specify only one attribute, so renaming is not necessary in case of natural join. So what is the difference between join and Cartesian product? So the main difference is in case of join operation we have to apply a condition, and based on the condition only those rows are just visible or appears in the resulting relation. So there is a condition in case of join operation, and in case of Cartesian product there is no such kind of condition. So all the possible combination of rows appears in the resultant relation. So here is the example to just illustrate the difference between join and Cartesian product. We have a table employee and we have also a table department. So when we apply a Cartesian product, so it is a combination of all the rows of table 1 and 2, and when we apply a join, then there is a condition department ID is equal to department number. So here that condition is same like this. Here the answer is correct. Like I have just corrected here 0 1 0 1 and 0 2 0 2 and finance and packing. So here the result is same 0 1 0 1, then finance and 0 2. Here it is also wrong, it is packing, it should be packing here, as no, it should be marketing. Yes, it is marketing, as department number 2 is marketing, so it is marketing here. So here also the result here it is marketing, it is not packing, as the department number 2 is marketing. So here the result is correct, it is a correct result. Finance marketing, when we apply a join by applying a condition department ID is equal to department number. So just we apply a condition department ID. So department ID here 01, so here the department ID is 01, so the department name is finance. And again in the second case department ID is 1, so the department name is finance. So we combine this with this table by just finding which department ID is same. In the second, Ankur has department ID 2 and department ID 2 has a department name marketing, so here is a marketing. So this one is join operation, and basically in this I am just illustrating the difference between join and Cartesian. So there is a condition in case of join and there is no condition in case of Cartesian product. So it just display all the rows by combining number of rows from two tables, but in case of this it displays only those rows that just satisfy the condition department ID is equal to department number. Also if we just remove this condition, then in that case it combine all the rows of first and second join first and second relation, that is imp and department, and in that case join is same as that of cross product. So thanks for watching this video lecture.